However, Expo is a framework on top of React Native that makes it easy to build cross-platform applications. All its codebase is open source. I searched for XState in the repository and found that XState was used in the Expo Updates package. I wanted to get the point of view of the developers who worked with XState at Expo. I contacted the developer who introduced XState in the Expo Update package, Doug Lowder. He agreed to be interviewed, and I thank him a lot for that.
Oh, yes. My name is Doug Lowder. I work at Expo. I've been a developer here for 2 years. I'm been involved in the React Native community for quite a few years now. I am the developer who built the React Native Apple TV port, and I maintain the React Native TV repo for Apple TV and Android TV, and have been working on Expo for their updates feature, and now for the notifications feature, and also support TV at Expo.
But what is Expo Updates? Maybe we can explain a bit what the purpose of State Machine and Expo Updates. I did a bit of Expo development, and I'm talking about under your review. But I think Expo Updates is to get a fresh JavaScript update from my application without downloading it from the App Store. Is it right? Or
That is correct. Yes. As long as you only make small changes to, for example, the JavaScript bundle, and things like that. If you make changes to native code, then you have to rebuild the app and you have to submit it to the App Store. But if you're making small changes that only touch JavaScript or TypeScript and only require that the bundle be rebuilt, then we have a system that allows that bundle to be served by the update server. And so and we have a protocol by which the application can reliably ask for whether a new update is available, and then if that update is available, it can download and it actually can reload the JavaScript engine with the new bundle.
okay, and is it something automatic, or can developers choose to reload the application while the user uses it?
Both. We actually have a JavaScript API for reloading the app on the fly while the person is using it, and then once you have an update that's considered the latest update, we have a database of those updates that exist on the client,
Okay.
and when the application restarts, it looks for whichever update is the latest and is known to be the right one. It launches that.
Okay. When you search for XState in the Expo repository, you find a state machine called Updates State Machine. The state machine uses XState4. In the file, we can find the events of the state machine. Then we can find some assign actions to assign new data to the context. Then there is a state machine with its context, the initial state, idle. We have 1, 2, 3, 4 states in the state machine. The first one is the idle state. In this state, we will listen to a bunch of events. We take some actions, and we do so in the other states of the machine. Finally, the restarting state is a final state, which means at this stage, the state machine will be stopped automatically. However, I couldn't find where the state machine was used. I could find some tests for the state machine, but that was all. Before the interview, Doug told me that XState wasn't used in the Expo Updates at the runtime. It was used to prototype a state machine that was later implemented in Swift and in Kotlin.
We decided that we needed to have a state machine because our update system manages in native code over-the-air updates, and it has to be very reliable. And we decided that in order to make it as reliable as possible, and in order for the JS layer to have correct and up-to-date information on the exact state of what was happening in the native code, we needed to implement a state machine inside the updates package. So we did that, and in order to make sure that we had the right state machine without trying to iterate very slowly in native code, we built a model of that state machine in XState, which turned out to be a great idea because XState is a beautiful way of modeling very quickly different state machines in TypeScript, which is the language that we used, and manipulating those and exercising those state machines on the web and in Visual Studio Code. And so several developers, including the other main developer that worked on Expo, were able to try out these models and suggest changes. And so we were able to very rapidly iterate and come to an agreement on exactly the model that we wanted. And just to make sure that we had a reference, we did check that model into our source tree. But that model is basically a reference for the native code that's actually used in production.
Okay. And did you use the visual tools that Stately to model the state machine, or did you stick with code for that?
We used both. Stately. We started out with Stately because it's so easy. So it's just right there on the web. But since we do a lot of our development on the TypeScript and JavaScript side in Visual Studio Code, it was nice to have that the plugin there that enables you to actually exercise the state machine there as well, and actually edit the state machine in Visual Studio Code and see the changes as they happen.
Yes. This is a Swift implementation of the state machine. First, we can find an enumeration of all the possible states, then an enumeration of all the possible event types. Then there is a bunch of structs that hold the payload of the events. We can also find the context of the state machine, which is a struct with a lot of booleans. And finally, the updates state machine class. The state machine class has a queue execution method, which is used to queue events and execute side effects. This is the current state of the machine. This is the context of the machine. The reset function is used to reset the state of the state machine by going back to the idle state and resetting the context to a fresh context. The process event function is used to take an event, see whether the transition can be taken, and if so, get the new context by giving it the current context and the event, and storing it in the state machine instance. Then it forwards the change to the JavaScript layer because, as we said, in the JavaScript layer there is no state machine. The state machine is implemented in Swift for iOS and in Kotlin for Android, and then those both native layers forward to the JavaScript layer what the current state of the machine is. The transition function, it checks whether the event is allowed and what the next state based on the current state and the event should be. To get the next value of the context, the reduce context method takes the current context and the event. Then, with this switch statement, it will return a shallow copy of the old context with some properties updated. Finally, we can find a map of the states and the allowed events in those states. For instance, in the idle state, the check, download, and restart events are allowed, but in the restarting state, no event is allowed. There is another map, but this time it's to determine what the next state should be based on the event. This state machine is quite simple, and one event should lead always to the same state. So if we receive the check state, whatever the current state is, it must lead to the checking state. But, as you can see, the check event is only listened to in the idle state. So the transition in this case will be, if we are in the idle state and we receive the check event, then we go to the checking state. In the Kotlin file for this state machine, we can find again a class. There is a queue execution function, the current state, the current context, the reset function, the process event method, the transition method again, and then we can find those maps. So the map is for all these states, we accept those events. This is the same thing as for the Swift implementation. The state machine is used at several places, but we will focus on this enabled app controller file. So in this class, we have the state machine that is defined there. Then we can see that, for instance, in the start method, we send like an event to the state machine with this queue execution function. And this time, we send it a startup procedure. Procedure is the way for the implementation Expo wrote to execute side effects with state machine transitions. I saw that you didn't use a state machine library for Kotlin and for Swift. My question, I don't really know these native languages. How is the support for state machines in Swift, in Kotlin? Why didn't you use a state machine? Could you use a state machine? That's my question. Because when I build state machines in JavaScript, I always use XState. And yes, how is it with other languages?
Well, because we were trying to keep our implementation as simple as possible and easy to maintain, we ended up basically building our own native classes that represented as closely as possible the state machine that we ended up with in TypeScript. So we just basically had a representation of the state and the context and just the sort of the bare minimum we needed to make things work the way we wanted. We're actually the state machine that we ended up with is actually not very complicated. It only has a few states. The most of the complexity is in the context changes. So we were able to get away with not having a very complex. If we had a more complex state machine, of course, there are native packages in both Swift and Kotlin that are designed for that, but we didn't really have to end up using those.
Yes. Even if XState doesn't run at runtime in an Expo package, it was used to quickly prototype a state machine that was later implemented in Swift and in Kotlin. State machines are required for complex problems like this one. But don't get me wrong, XState not running in an Expo package doesn't mean that you shouldn't use it in your userland code. And what do you think about using state machines, or more specifically XState, in userland code in React Native applications?
I think I could see it being extremely useful for certain types of applications. And if I ever come across a use case that requires a state machine actually in the JavaScript bundle, that will be the first place I look. Will be XState for sure.
Yes, great. One thing I like to implement with XState in my React Native application is authentication, because I know that with the most modern Expo versions, there is now the Expo router to use file-based structure to define pages. But previously, I've been using React navigation, and you had to declare the routes based on the authentication state or other things. And I like to use XState to control all those authentication flows that can become complex the more you add features.
Yeah. I could see that being very useful, particularly if you have more complex authentication setups. So, yeah, I do agree that Expo Router has done a good job of solving some of those issues. It's sort of a state machine in a sense itself. Everything the routes actually define state. You can never be in anything other than one of the routes that's allowed. So it that's I'm still I'm actually been spending a lot of time learning how to build things with Expo Router recently in the past few months, and I'm really liking the way that it sort of makes sure that you stay with you. You basically know exactly in all of the states or the routes that the system can be in.
Thanks a lot for having watched this video. I want to thank Doug again for having accepted my invitation to talk about XState at Expo. You can find him on GitHub, where he contributes a lot to the React Native ecosystem. I hope you liked this video. Please tell me in the comments. Bye.